So it's time to know what do you mean by alkynes. So what do you mean? What do we mean by alkynes? So don't get confused with alkenes. And I'm pronouncing alkene. It has got spelling alkene, L-K-E and E. So these are different spellings, also the different names and different structures also. So alkenes, so alkynes and alkenes, don't get confused. I'm stressing alkynes, and I'm stressing on the word, on the alphabet Y, alkynes. See, stressing here. So, so don't get confused with alkenes and alkynes. Now in the last two videos I taught you about the alkanes and alkenes. In this video we will see what do we mean by alkynes. So alkynes are the hydrocarbons, or you can say just carbon compounds. So actually these are also hydrocarbons, the unsaturated hydrocarbons. So these are unsaturated hydrocarbons. So these are unsaturated hydrocarbons. Now now alkenes, the alkenes, we say alkene to a compound when there exists a triple bond. So when there exists a triple bond between carbon atoms of the compound, so triple bond, when there exists a triple bond. I will write in a more neat handwriting. Yes, that's good. So triple bond. So when there exists triple bond, these are known as alkynes. So now the basic formula for alkynes is CnH2n minus 1. So better write it. So we have CnH2n minus 2. Sorry, it was my slip of tongue. Apologize. Sorry. So it's 2n. So CnH2n. So if I have got the number of carbon atoms equal to 2, then my hydrogen atoms will be 2 to the 4, 2 to the 4 minus 2, which is equal to 2. So the molecule will be, or the compound, the carbon compound of the molecule will be C2H2. So this is the basic formula for alkynes. Now as you might have, in the last video, you might remember from the last video actually, about propene, or yes, propene. Let's take propene. So it's an alkene. How do you understand it's an alkene? You say, hey, it has got a suffix ene, and as you told in the last video, that if the suffix is ene, then it's an alkene. So yes, it's absolutely correct. But in alkynes, as we are focusing on alkynes, the suffix for alkynes is y-ne. Just as we have got e and e in alkenes, we have got y and e in alkynes. So it stands as the y and e, the three alphabets stand as the suffix for alkynes. Now let's clear it with an example. So I have got here propene. So I have got here oops, so I have more colors. So I have got propine, actually not propene. So I have got propine. Whoops. Now again, don't get confused with propene and propine. Propene is an alkene and propine is an alkyne. It sounds very similar. Understand? So propine. Now you might pause the video and guess about the formula for propine. So the formula for propine is, as it has got a prefix prop. So as it has got a prefix prop, there will be 3 carbon atoms. So as there is a prop, we will get 3 carbon atoms. So we have got 3 carbon atoms, and as there is So the suffix is y and e, and it's an alkyl. Hence we can derive the hydrogen atom, number of hydrogen atoms from this formula. So we have got n is equal to 3. So we have got n is equal to 3. Therefore we will get hydrogen atoms equal to 3 to the 6 minus 2, which will be equal to 6 minus 2 equal to 4. So we will get hydrogen atoms equal to 4. We will 4h, therefore hydrogen atoms. Hence the formula will be C3H. I will use the same color for same elements. So C3 and H4. So this is propine. So this is propine. This is propine. Now let's draw the structure of it, the line structure of it actually, because mostly the line structure is used and dot structure is rarely used, though I have introduced about both of them. So line structure, we will get a C carbon atoms. As it's an alkyne, there should be a triple bond. Actually there's the most of triple bond. So C, and now it will get 3 to satisfy its valency. So it is sharing one electron with this carbon and one electron with each hydrogen atom. I will mark the hydrogen atom with blue. Getting a little shabby, but sorry for that. So see, and then there will exist and triple bond. So there will exist and triple bond, and then we will get another C. So this is sharing 3 electrons, yet it needs one more electrons, which it will take from the hydrogen atom. So I will show this also with blue signs. So let's see. So we have got 4 hydrogen atoms, so this has been satisfied, and we have got 3 carbon atoms, so this is also satisfied. 1 2 3. So this is the the line structure of propine molecule. This line structure. Now there don't exist a triple bond between these two carbon atoms. Now you will say why? Because it has been the tetravalency, the tetravalency of the carbon, it's been satisfied because it has got more 3 hydrogen atoms that are ready to share. So there is no need of forming triple bonds, which unlike of this carbon atom, which is only sharing one electron with this carbon atom, and it has got no hydrogen atoms to take to borrow to share the electrons. So this was all about the alkenes that I know. So in the future videos we will talk about some more not complicated, but some more concepts about carbon compounds.